Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss how to insert the nodes in a circular double linked list. I will discuss the three scenarios. One is inserting a node at the beginning, inserting a node at the end, insert the node after a specified position in the circular double linked list. So I request everyone to watch the complete video for better understanding. Before discussing about insertion, let me give an overview about the circular double linked list. What is a circular double linked list? It is a collection of nodes where each node will have the address of the previous node, data and address of the next node. If you look at here, we have collection of three nodes and these nodes are there in the address location such as 100, 200, 300 respectively. Look at the nodes. It has the address of the previous node, data and address of the next node. If it is only double linked list only, then address of the previous node in the first node will have the null because before this there is no node. So address of the previous node will be null. Even address of the next node in the last node will be null because after this node there is no node. But when it comes to the circular double linked list, the last node will be pointing to the first node and first node will be pointing to the last node. So here address of the next node will be address of the first node, which is 100. Similarly, in the first node, address of the previous node will be address of the last node, which is 300. And to identify which is the first node and which is the last node, we will have two pointers called head and tail, which consists of address of the first node and address of the last node respectively. Now, let me discuss how can we perform insertion in a circular double linked list at the beginning. Okay, to do that one, let me write a user defined function called insert at begin. Okay, and this function does not return any value, so that's why return type I have specified as void. Now if you want to insert a new node, first you need to create that node. So to create a node, first we need to declare a pointer of strut node. So strut node new node. Okay, then using malloc function we will allocate the memory. So new node is equal to strut node star. We will do the typecasting because malloc function will return a void pointer, but however new node is a strut node pointer, so that's why we are doing the explicit typecasting or type conversion. Then we are using malloc function and we need to specify the size, so we are writing size of operator and then we will write strut node. Okay, is it clear? So using the malloc function we will allocate the memory during the runtime. Okay, so how much size it will be specified by the size of operator, that much size of memory will be allocated and the base address will be assigned to the new node. Okay, due to some issue memory has not been allocated, then malloc function will return a null value. Okay, let's assume that the memory has been successfully allocated and the new node pointer is having the base address. Okay, now once you have created a new node, then you have to ask the user to enter the data. Printf enter the value or enter the data. Whatever you want to write, you can write within the printf statement. Once the user has entered the data, you have to read it with the help of scanf function. As we are reading an integer, I am using the format specifier as %d and I want to store it in a member called data, so that's why I am giving its address. Once it is done, I need to write new node of previous is equal to new node of next is equal to null. Let's assume that we have created a new node in the address location, let's take that 50, and it is having the data as, let's take that 5. Just for your understanding I'm taking, and we assign null and null here. Okay, now new node, let me write here, new node will have the base address which is 50. Okay, now you want to insert at the beginning. Is it clear? Means here you want to insert. Before doing that one, you need to check whether the list is empty or not. If list is empty, meaning is that there are no nodes in the circular double linked list. If there are no nodes, whatever the node you are inserting will be the first node and will be the last node. So how can we check the condition whether the list is empty or not? If head is equal to null, then I can say that list is empty. Okay, so if list is empty, what I will do is that this will be my first node and this will be my last node. So then I will write head is equal to tail is equal to new node. Okay, so new node is consists of 50. So head and tail, let me write it as shortcut as, okay, don't write shortcut, let me write full one. Head and tail will be assigning 50 and 50. Is it clear? So head and tail pointers are pointing to this node. Okay, is it clear? So now what you want to do? We want to have the addresses, because it is now null, they are not pointing to it, but I want to make it as a circular double linked list. How can I make it as a circular double linked list? I can write here as head of previous is equal to tail and tail of next is equal to head. Okay, now look at here. Head of previous, head is 50, 50 of previous means this one you are telling. Okay, then what you are assigning tail, what is tail is consists of 50. Okay, then tail of next, tail is 50, 50 of next is this one, you are assigning head which is 50. So this node is pointing to this node and now it is pointing to this one. So it is a circular double linked list. Is it clear? Else, if head is not equal to null, there are some nodes in the circular double linked list. If it is so, what I should do, I will discuss now. Let me erase this one and we have a new node in an address location 50 and have the value 5 and here null is there and here null is there. Now if head is not equal to null, meaning is that some nodes are there and you want to insert at beginning. So here you want to insert. So what are the changes or what are the things you have to do? Let me discuss now. So let me write the else block. Okay. In the else block, what I am doing is that first thing I have to write this one. See, now what it should be, new node of next should have the 100. Am I right? Because if this is the new node you are inserting, let's write that here you are inserting. I hope it is visible for you. You are inserting here. So now this node should be connected to this one. This node should be connected to this one. So first, how can you connect this node to this one? So how you can do is that new node of next is equal to head. Look at here what is head is consists of. Head is consists of 100. Okay. So let me write big one so that it will 5 you have. Okay, and what we have written, new node of next is equal to head. New node is 50, 50 of next is this one is equal to head. So you have created forward link. Okay, this node is connected to this link. Now what it should have here, head of previous should have the 50. Am I right? This node should be pointing to this one. So what we will write here is head of previous is equal to new node. Okay. Now head of previous, head is 100, 100 of previous is this one, should be consists of 50. So you have connected this one. Now this link is down. Am I right or wrong? Is it clear? Are you able to understand? Now what we have to do? We have to make head is equal to new node. So now head is equal to new node means head will consist of 50. So this head is pointing to the first node. Always the head should be pointing to the first node. Yes, it is good. Now what we should write? Here we have to write head of previous is equal to tail. Okay, if it is so, head of previous, 50 of previous means this one. Are you able to understand? So this one, what we are writing? tail. Here you will get 300. So there is will be a link like this. Are you able to follow with me or not? Okay. Now still this node is connected to this node, but this node should be connected to this node. So how you can write tail of next is equal to head. Tail of next is equal to head. So tail of next, tail is 300, 300 of next is this one, is equal to head 50. So now this node is connected to this node. Are you able to understand like this? Okay. So whether we got the circular double linked list or not, you check it. The new node has been created and forward link has been established, backward link is established. Now this first node is pointing by the head and it is having the last node address and this is having the address of the first node. So we have successfully inserted new node at the beginning. Is it clear? I hope you have understood. Okay. And now still look at head is pointing to the first node and tail is pointing to the last node. So we are done with the else block and we are done with the function. So this is the way we will insert a new node at the beginning in a circular double linked list. Now let me discuss how can we perform insertion at the end. Let me erase this one. Insert at end. Okay, again we have to create a new node. New node is equal to strut node of malloc. All these things will be there. Printf, enter the value. Scan of percentage, this all parts will be there. New node of previous is equal to new node of next is equal to null. If head is equal to null, this part will be same as it is. Else block only will be changing. So that block only I am modifying for you. Okay, is it clear? I hope you are understanding. See, even if you want to perform insert at end, you need to create the node. So to do that one, I am writing these two lines. Once you have created the node, you have to insert the value. So that is why we have written these two lines. And new node of previous, new node of next is equal to null. Then I am checking. If the list is empty, again the first node will be the last node. The code will be same. Else block, it will vary. Now else block, what will happen? We will discuss now. Now we have created a new node, okay, in some address location 400. Let's take that. And user has entered the value 40 and we have assigned null and null here. Are you able to understand? And this node we want to insert at the end. Now new node pointer will have the address which is 400. Is it clear? Now what are the things we have to do? One is that I need to create the link between this node to this node. One is the task and another one is that I need to update these links also and I need to update the tail. So 5 things I need to do. So first one is that what I can do, new node of previous is equal to tail I can write. So new node of previous is equal to tail. What will happen? You check it. Okay, new node of previous, this one new node is 400 of previous means this part is equal to tail. So you will get 300. So you have connected a backward link from this node to the previous node. We have connected. Are you able to understand? Now this node has to connect to this node. So how can you write? Tail of next, you can write tail of next is equal to new node. Tail of next, this one, tail of next is this one, is equal to new node, so 400. So this link will be down. Whatever the link we have created, that will be down, and this node will be connected to this node. So you have connected the forward link also. Are you able to understand it or not? Then what are the things we have to do? We have to move the tail. So how can I move the tail? New node is equal to tail, because always the tail should be pointing to the last node. So new node is equal to, tail should be equal to new node. Sorry for it, because we want to update the tail, not the new node. Okay, so what we have to write is that tail is equal to new node. Sorry for the inconvenience. It happens sometimes. I think you can also understand. So tail is equal to new node. What is tail is new node is consists of 400 that you are assigning to the tail. Is it clear? So now tail is pointing to the last node. Okay, well and good. Now what are the other things you have to do? Here you have to update. What is you have to update is that tail of next is equal to head. Okay, tail of next means this one is equal to head, which will be 50. So there will be a circular. So this node will be connected to the first node. Are you able to understand? Okay, let me write it for you. Okay, done. Now this one should be pointing to the last node. So how we have to do? We will write head of previous is equal to tail. Okay, head of previous, head is 50, 50 of previous means this one is equal to tail, which will be 400. So this link will be down and this link will be established. So like that we have created the circular double linked list and inserted a node at the end. Is it clear? So we have to update the 5 values. That is what we have written here. Is it clear? So if you still have any doubts, you can create another node and you can insert at the end. So let me close the else block. Let me close the insert at the end. So this is about inserting at the end. I hope you have understood. Now let me discuss how can we insert a node after a specified position. Okay. So to do that one, let me erase all these things. Let me have the head and tail. Head will be 50 and tail will be 300. Okay, so if it is so, what will have? It will have the 300. So you have a connection like this. The last node is connecting to the first node and here you will have 50. So this node is connecting to the first node. So that is what the circular double linked list. I hope you have understood. Now user want to insert a new node after a specified position. Suppose let's take that user has entered the position 2. After second node he want to insert. So in between these two nodes he want to insert. Suppose if user says position is equal to 3. After third position he want to insert. So after this node he want to insert the new node. So that is the way we will insert the new node after a specified position. Let me discuss the C program for it. Okay. Let me erase this one so that I will use this space to discuss the C program to insert a new node after a specified position in the circular double linked list. I hope you are enjoying the video. Maybe it is lengthy, but it is worthy to learn. Okay. So let me write the user defined function called insert at or insert after position, because we want to insert after a specified position. Okay. So to do that one, I will declare two variables called POS and I is equal to 1. Now position, I will ask the user printf enter the position where you want to insert, after which position you want to insert. So enter the position. Once the user has entered the position, you have to read it. So with the help of scanf function, you will read it. Now look at this one. After we have read the position, we have to see whether this position is valid or invalid. Why I am saying whether it is valid or invalid? Let's take this case. How many nodes are there? 4 nodes are there. So if user says that insert after the first position, then it is valid because after this one you want to insert. Good. If user say position is equal to 4, after this position you want to do. Okay, valid. If user says that position is equal to 10, if you have a list of 4 nodes, how can you insert a new node after the 10th position? It is invalid. So what we have to do is that we need to count the number of nodes in the circular double linked list and we have to check whether it is valid or not. So what I will do is that I will take an integer variable count and then I will call a user defined function called length. Okay, what this length purpose is, it will need to count the number of nodes in a circular double linked list. Is it clear? So let me write the user defined function called length. Okay, oh, I should not write void. What I should write here? Int, because this function is returning an integer value. So return type you have to specify is int, and you have to write the function name length. Then we will declare a pointer called temp of strut node, and we will assign the head value. Okay, and then we will take another integer variable I is equal to 1. Are you able to understand? So we are taking a temp and we are assigning the head value, which is 50. Now what I have to do, while temp of next not equal to head, then what I need to do is that I need to increment the I plus plus, temp is equal to temp of next, then I will return the I value and I will close it. Now let's see whether it is working or not. How can we check? We will take this one and we'll check whether it is giving the length value as 4 or not. Okay, so look at temp is 50. So 50 of next is 100, which is not equal to head 50. Yes, 100 not equal to 50. So this condition is true. If this condition is true, what are the statements which are there? Two statements are there. You have to execute these two statements. One is I plus plus. So I value is initially 1. Now it will become, let me write here, I value is 1. Now it will become 2. Okay, are you able to understand? Then temp is equal to temp of next. Temp is equal to temp of next means here temp is 50, 50 of next is 100, 100 will be assigned here. Are you able to understand? Then again you will check this condition, temp of next is 100 of next, which is 200, that is equal to 50. No, again the condition is true. If again the condition is true, you have to do these two statements. One is I plus plus, I value is 2, 2 plus plus will become 3. Temp is equal to temp of next. Temp is 100, 100 of next is 200, that you are assigning to the temp. Okay, done. Now again you will check the condition, temp of next not equal to head. Temp of next temp is 200, 200 of next is 300. So you have to check 300 is equal to 50. No, 300 is not equal to 50. Again this condition is true. If this condition is true, I plus plus. Now I value will become 4. Temp is equal to temp of next. Temp is 200. 200 of next is what? 200 of next is 300, that you are assigning. Are you able to understand? Don't get confused. Temp is 200. 200 of next is 300, that you are assigning to temp. So now you are getting 300 here. Again you will check the condition, temp of next not equal to head. Temp is 300, 300 of next is 50. So 50 is equal to 50, but they are saying 50 is not equal to 50. So this condition will be failed. So if this condition is failed, it will come out from the while loop. If it comes from the while loop, what is the statement is there? Return I. What is the I value? 4. That value 4 will be returned and count will get the value as 4. I hope you are understanding. So this is the way we will write a user defined function called length to count the number of nodes in the circular double linked list. I hope you have understood. Okay. Now what I want to do? I want to check the condition. If position is greater than count, then I want to say that invalid position. So let me write here printf invalid position. Else, if the position is valid, what I want to do, we will discuss now. If the position is valid, first we need to declare a pointer called strut node new node because we need to create a new node. Okay, let me write here new node and I will allocate the memory using the malloc function. So I will write here as new node is equal to, okay, new node is equal to strut node star malloc size of strut node. Okay, is it clear? I hope it is visible for you. Then we will ask the user to enter the value. Printf enter the value. Okay, once the user has entered the value, we need to read it. Scanf %d ampersand new node of data. Is it clear? Are you able to understand? Then we have to write the statement as new node of previous is equal to new node of next is equal to null. So let's assume that we have created a new node, okay, and inserted some value as 15. Let's take that here we have inserted 15 and here we have assigned null and null. Okay, and its address is, let's take that 400. So now new node will have the 400 value. Now let's assume that user has entered the position is equal to 2. If user has entered the position is equal to 2, I value is 1. See, don't confuse with that I value previously and this one, because this I is a local variable for this function called insert after position, whereas that previous I where you got I is equal to 4 is a local variable for the function called length. Okay, is it clear? Now position is 2 is less than count, so it is a valid position. If it is a valid position, we can perform the insertion. So how can we insert is that we need to traverse up to position is equal to 2. Here up to here we have to traverse, then only we can update these links. So how can I traverse up to there is that I will take one pointer called temp. Strut node star temp is equal to head I will write. Okay, are you able to understand? So we have created a temporary variable called temp, and not a variable, it is a pointer, and we are assigning the head value. Head value is 50, so we have assigned the 50 here. So this pointer is also pointing to the first node in the circular double linked list. Okay, now let me discuss what are the steps we need to follow if you want to insert the new node at the after the specified position. First I need to traverse up to there. So how I will traverse? While I less than position, okay, then I have to write temp is equal to temp of next, then I plus plus. Is it clear? So let me close the while loop. Look at here what will happen. I less than position, I value is 1, position value is 2. 1 is less than 2. This condition is true. If this condition is true, you have to execute this statement. Temp is equal to temp of next. Temp is 50. 50 of next is 100. You are assigning to the temp. I hope you are able to follow with me. Then I plus plus. Now I value will become 2. Now temp is pointing to this node. Okay. I plus plus I value will become 2. Again you will check the condition. 2 less than 2. I is 2. Position value is 2, 2 is less than 2, no, 2 is equal to 2. This condition is fail. If this condition is fail, it will come out from the while loop. Now look at what is the temp is pointing. Temp is pointing to this node. Okay, are you able to understand? Because you want to insert the node after the second position. Yeah, it is valid. Are you able to understand? Now what you have to do? You have to insert this new node between these two nodes. So what I have to do is that here it should have the 100 and here it should have the 200, like that I have to do. So what I will do is that I will erase this one first and I will use this space to do it. So what I will do is that new node of previous is equal to temp. Then what we will get? New node is 400. 400 of previous is this one, and you are writing 100. So you have connected this node to this node. Is it clear? Previous node is this one. You have connected in the backward direction. Are you able to understand? Then what you have to do? You have to update this one. So what we will write is that new node of next is equal to new node of next, this one is equal to temp of next. Look at here what will happen. First let's check temp of next. Temp is 100. 100 of next is 200. That you are assigning to new node of next. New node is 400. Of next is this one. So you are assigning 200 here. So this node is connected to its next node. Are you able to understand? Is it clear? So these links will be erased. Okay, still they will be there. Okay, don't worry with this one. We have connected this one. Now what we have to do? These link nodes are still, these links are there because these values we have not updated. Only this one. This node is connected and this node is connected to this one. Now I want to update this one. What this value should be there? It should connect to this node. Am I right? You have connected the backward link. Now you need to connect the forward link. How you can do? How we can do is that we can write temp of next is equal to new node. Temp of next, temp is this one, 100. 100 of next is this location. You are saying new node. What is new node value? 400. So this link will be down. This link will be still there. This link will be down and this link will be connected like this. Are you able to understand? So meaning is that, let me explain here. We have taken that this is the previous node. So now you have connected like this. Are you able to understand it or not? Now what you have to do? This node should be connected like this. Am I right or wrong? Backward link should be established. So how you will access this one? This is one of previous. So how you will write is that new node is 400. 400 of next is 200 of previous. Meaning is that this location you are talking. See, you want to access this location. How you can access? New node is 400. 400 of next is 200. 200 of previous is this one. What you want to assign here? You want to assign the new node value. So what is that one? New node is 400. So this link has been connected like this. So what I want to say is that finally this, I hope you are able to understand. The board is shaking. Sorry for the inconvenience. This node is connected like this. This node is connected like this. And this node is connected like this. This node is connected like this. So we got the circular double linked list. I hope you are understanding. Let me close the else block. Let me close the function. Okay, so this is the way we will perform the inserting a node after a specified position. I hope you have understood how to perform the inserting a nodes in a circular double linked list. We have discussed the three scenarios. One is inserting a node at the beginning, inserting a node at the end, inserting a node after a specified position. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. In the next video, I will discuss how to delete the nodes in a circular double linked list. I will discuss the three scenarios. One is deleting the node from the beginning, deleting the node from the end, deleting a node from a specified position. If you want to learn the deletion in a circular linked list, I request you to go and watch the next video. Thank you for watching this video. Have a nice day.